Hello, in this video, I will be talking about describing the data. These are all measurements that represent the center of the data. And the first measure of the center is the mean. You may recall that the mean is the average. And you also remember that in order to find the arithmetic mean, you'll have to add all the values and divide by how many values are there. In statistics, I write down the formula using the symbols, summation of x all over n. And let's just make a note here. Summation is actually the symbol for adding all the numbers. We talked about this in the previous video, but I'll write it down here also. X is any data value, and n, lowercase n, is the sample size. So let's take a look at this example right here. This is example which displays the data in what we call a dot plot. And this is about prices in dollars per night of hotel rooms in a city. As you look at this graph, you should be able to grasp the information. And if you want to write down the raw data, you can. I will write down a few of these values just to make sure you understand how the data looks like. For example, I'm looking at this dot right here, and that will be $170. And then continuing, I look at this one and so on. So the next one is 180. Then I have a 190. If you look at 200, I have two 200s. And if I look at 210, I have 5 210s, and we can continue. I will not continue. I will just leave it for you if you want to continue. And if I ask you to actually come up with the mean of this one, you will take the calculator and you will add all of these values, including this, all of these, okay? And divide by how many values you see there, which means your average will actually come up to 207.33. And you see that I am already using the symbol. This is the mean. If you use a sample and you are finding the mean, then you use this symbol right here to the left, and it is the sample mean. It is used to find the sample mean. So in this case, we have 207.33. Now you may wonder what is going on with this symbol right here. This is what is going on. If, and I'll just put down a big if right here. If you look at these values as an entire population, in other words, if the entire population is used and you continue the process and you find the mean, then the notation for the mean is mu. This is a Greek letter, mu, and this is actually the population mean. Okay, so if someone looks at this data and says, you know what, that's my population, which theoretically makes sense, practically it doesn't make any sense, right? But let's just assume it's a big if right here. Then the result, this result right here, will be denoted with mu, not with x bar, and that will be the mean of the entire population. You should use the proper notation. Keep in mind, this is a parameter. We already knew that, right? So any information measured that comes from the population is called a parameter. And this is actually a statistic. Something else about this, and maybe a way to remember, usually Greek letters are used to denote parameters, while Roman letters are used to denote statistics. Let's talk about the median. The median is the middle number or ordered array. This is very important because if you miss this, you'll make careless mistakes. Make sure you always order, okay? So we will be looking at this example right here, and this is example 2. If you want to practice, you can go back to the previous problem and find it using the previous example. I'll simply use this example right here. First of all, let's make sure we understand what is this all about. Well, this is about grade point average of students in a class. Looking through it, you will see that the data values are actually decimals because the key tells us so. So if you want to have an idea or making sure you understand, try to just write down a couple of these. The first one is 0.8. Then I see a 1.5 right here. then a 1.6, a 1.8, then a 2.1, and so on. I will not list all of this. This is just a good practice, especially if you are confused, you don't know really what is going on with this data. Try to get a feeling of how it looks like. What we will try to do, though, is find the median or the middle value. Here we go. First of all, I want to make sure that this is in order, and looking at these values, I realize that this is an ordered stem leaf plot. So what I will do, I will simply try to get to the middle. I will cross the first number and the last number, and then crossing the numbers like this, I will arrive at the middle. And because I have an even number of values, I am left with actually two numbers in the middle. These are the leaves, and this is the stem. So my two numbers in the middle will be 2.3 and 2.4. How do I arrive at the median? Well, you will simply find a midpoint in between these two, and that will be 2.35. And this is the median. The median doesn't have a specific notation. For this example, I'll just write down median equals 2.35. But now I will move on to the next slide. The mode is another measure of the center or measure of central tendency. So let's talk about the mode. The mode is the most frequent or the most common value in a data set. If you look at the example on the right side, this is about weights in pounds of carry-on luggage on a plane. And again, use the key to identify the values. This time we do not have decimals. All you have to do is look for the most common value. It doesn't matter that these are or not in order. By the way, these are in order, but with the mode, this will not really help us. They don't really have to be in order, but it's easier probably to spot the most common value. Here I have 3 leaves that belong to the stem of 2, and here I have 3 leaves that belong to the stem of 3. So right here, I seem to have number 24 that repeats 3 times, and number 35, which means the mode is both of these. Keep in mind, you can have 2 modes, you can have no mode, you can have 3 modes, as long as you are looking for the most common value. It is possible to have more than just 1 mode or no mode at all. And now the next one, which is not very popular though, but we will talk about this. This is the mid-range. The mid-range is actually the middle of the range. So in order to visualize this, let's just look at the lowest value here. The lowest value here is 6 pounds. Okay, and the largest value here is, well, right here, 51. So what will be considered the middle of the range is actually the midpoint between these two values. So if you do the math, you will get 6 plus 51 divided by 2, which will be 57, divided by 2, which is 28.5. This will be the mid-range. Okay, so mid-range, you can write this down, lowest plus highest value, and that should be divided by 2. And now you can go ahead and practice finding all of these measures using this next example. And after you practice, let's see if you got the same values that I got. So I will simply write down the results. So for this example, and because I have a sample, I'll be using the proper notation, okay? This is about the number of weeks it took to reach a target weight for a sample of 5 patients. So right here, I have X bar, and I got 16.6 weeks by adding and dividing by 5. And then the median, in this case, is 15 weeks. Something about this problem, put it in order. Make sure you put it in order to come up with this answer. For mode, I got no mode. And for mid-range, using the formula, I got 16.25 weeks. And I simply used the formula, did not use the calculator. But what I will encourage you to do is these 2 measures using the calculator. These ones are not in the calculator by default because you can easily find it by hand. But these 2 are by default set in the calculator and I'll show you how to use it. First thing you will do, you will go to stats and edit. You need to put those values in a list. I'll hit enter, and I already have some values on my list, so I'll go to the top and clear that and then hit enter. Then go to the first list on the top, clear that and hit enter. And now I need to put my values and I'll put it in list 1. So here we go, 15, hit enter, 31.5, hit enter, 10, 25.5, and 1. Okay, and all you need to do now is click on stats and then go to calc using arrow. Now on this screen, you'll see many functions the calculator can do. We will use this for the first part of the semester, actually, quite a lot. So don't change that from here. It's variable statistics for one variable. Hit enter, and you should see a screen similar to this. Okay, if you don't see a screen similar to this, then you may want to enter the list. So you may want to do this. So one variable stats, you may just see these simple instructions. And then you will have to put list 1, or if you have the values in a different list, you will put list 2. If you put nothing in here, then the calculator by default will take the values in list 1 and find the variable statistics for that one. Now, if you have this list, so I'm coming back here, make sure you have list 1. And for frequency, make sure you clear if you have a list in there, because for our problem, all we have is in list 1. Okay, and then hit calculate. And when you do that, you will get the 16.6. So this is what we got by doing this by hand. This is the mean. You see some summations right here. You see some other symbols. For now, you are not interested on that. And if you scroll down, you see the median, right? And some other values, very important values. But for us, we're interested only on the median at this point. So now I will get back to our problem and continue. We will be taking a look at the mean and skewness. Let's take a look at this example. For the left example, you do see that distribution is skewed to the left. On the right example, you see a distribution that is skewed to the right. Now, right here, it tells you that the mean is 6.3, the median is 6.5, and the mode is 7. Okay, let's see if this makes sense. Mode is the most common value, so of course, it will be the tallest, to be corresponding to the tallest bar. The easiest to be found for any distribution will be the mode, right? Now, the mean is affected by these many lowest values because this is skewed to the left. It will affect the mean. So keep in mind, the mean is affected by lower values or higher values. The median is somewhere in between, okay? Now, on the opposite side, if you have a distribution that is skewed to the right, that means you have many values right here, many large values, and this will affect the mean. And that is true. Look at this. It's kind of pulling the mean toward the direction where the distribution is skewed. So mean right here, it's 7.7. The median is 7.5. And the mode is the tallest bar right here, which will be 7. So keep in mind, whenever we have large values, or even if we have a very large value, and by the way, if we have a very large value, that is called an outlier. So let's just assume in this case, we have something like 20. It seems like it doesn't belong in the data set, right? And we will look at this and wonder, is this an outlier? In order to answer the question, we will learn methods to identify outlier. But anyway, a value that is extreme will have a great effect, especially on the mean. The mean will be the one that's affected the most. And actually, that's how distributions become skewed, because there are there is a possibility that there are outliers that will pull that tail toward one direction or other. Let's just take a look at the next slide. Again, about the shape of distributions. and how the mean, median, and mode look like. For a symmetric distribution, the mean, median, and mode should be approximately the same, right there in the middle. For a skewed left distribution, we already saw that on the previous slide, the mean is pulled toward the left side. The mode is the tallest bar and the median is somewhere in between. And for the other distribution, we have for the right skewed distribution, we have the mean to the right and then mode, the tallest bar, and in between we have the median. Moving on. Okay, so probably until now, nothing got too exciting because you knew most likely about the mean, median, and mode. But let's see how do we deal with this type of problem. Here we go. We have to find the mean. But this time we have to find the mean of a grouped frequency distribution. And if you do recall, a grouped frequency distribution is actually a table which is based on classes and frequencies. And this is what you see right here, the table. These are the classes. Keep in mind, this is where data are, and this is the frequency. So fuel economy, the highway mileage in miles per gallon for 30 small cars. We have 30 small cars, and we know that 11 of those will have a mileage between 29 and 33. The problem is we don't know what exactly those values are. We know there are 11 in this class, there are 12 in this class, and so on. So we are wondering, okay, how do we find then the mean? Just to make sure we understand, here is the example as a raw data. I know it's very tempting to just take these numbers and add and divide by 5. That's what some students do, and that is wrong. Keep in mind, this is where the data are in these classes, and I don't really know what these values are. I just know that 11 of these values are between 29 and 33. So what I do, I will get the best estimate I can get by creating another column. And what do I put in that column? Well, you may have guessed that the best estimate for a class will be the midpoint of each class. So I'll be using the midpoints for the classes to come up with the best estimate. How do we find the midpoint? Well, I'll just do this in here, 29 plus 33 divided by 2, and that is 62 divided by 2, which will be 31. So this is my first midpoint, the midpoint of the first class, okay? That is 31. And then I'll simply look at the class width, which is 5 in this case. So I'll have 36, 41, and 46. So this is what I'm gonna do. I don't know what these values are, but I can say that if I estimate all of this value as being 31, I'll have 11 31s. So I have 31 11 times. Just want to give you an idea of how this looks like. I'm not going to write down 31 11 times. I'll just say, okay, you write that down this many times. And then you have 12 values in the second class, and I will simply estimate it by writing down 36 12 times. I'm not actually writing this down. I just want to give you an idea of how this data looks like, right? To understand what we are doing here. So can we find the mean now? Yes, we did approximate, but that's the best thing we can do by using these midpoints. This is very important, the midpoint formula. So this is what I will do. You can actually add all of this data and divide by 30, right? But I'll show you, I'll write down the formula. The easier way to do this would be to actually follow this formula, which is summation of the frequency times the value divided by summation of the frequency. And I hope this makes sense. Instead of adding 31, 31, 31, 31, 31, 11 times, I'll just do 31 times 11. And then I'll do 36 times 12. And let's just actually do that here. 31 times 11 plus 36 times 12 plus 41 times 2 plus 46 times 5 all over 30. Okay, I'm not gonna do this because I want to show you how to use the calculator in this situation. Okay, but if you want to do this, you will find out that you get the exact same answer. So let's just use the calculator. In order to use the calculator, I will explain what we're gonna do. We put these values in list 1, the midpoints or the data values in list 1, and this time we are using another list, which is the frequency column. This will be something that we enter in list 2. We will repeat the process that I just showed you for one list, meaning we will click on stats. Let's just explain right here, edit. And this is how we'll explain. In L1, we put the midpoints. In L2, we put the frequency. Then go back to stats and click on calc or use arrows to get to calc. And on calc, pick one variable stats. For list, you say, I have my data in list 1. For frequency list, you have to fill in list 2 and then calculate. And you will get the information related to the mean of this distribution. Let's do that. So right here, I have the calculator and I will enter the information, go to stats, edit. I'll clear my list. List 1, I will enter the midpoints, 31, 36, 41, 46. Now on the second list, I will enter the frequencies, 11, 12, 2, and 5. Okay, now I go back to stats and I will use arrow to get to calc. One variable stats, it's highlighted. We keep it this way. Hit enter. Now I have my data in list 1, which are the midpoints. And on the frequency list now, right here, I have to enter the second list, which is under 2, second, 2, and then calculate. Now, if you do not have this screen, as I told you in the previous video related to, in the previous calculator work, you will need to enter the second list this way. One variable stats, comma, list 2. And this is a must, because if you don't do that, the calculator, if you don't include the list 2, the calculator will just do list 1 by default, and you'll get wrong answers. So make sure you take care of this. And comma is very important in statistics. It has its own key. It's above 7. That's comma. So second 1 for list 1, comma, second 2. Okay? And then hit enter. And 36.17 is the mean for the group data from that slide, 36.17. One more example. This is related to the weighted mean. The formula for the weighted mean is very similar to the formula for the group frequency distribution. And I'll write down the formula right here. It is summation of the weight times the data value divided by summation of the weight. So this is the weighted mean because each data value comes with a different weight, like in this situation. And this is actually a situation that is used in education quite a lot because all grades are weighted. Final grade, the scores and their percents of the final grade for a statistics student are given. What is the student mean score? So in this case, we are given the actual data value, which is the score. Okay, this is where you find the data in this column. And this is the weight. So this will be the weight of each category. Okay, so let's see how can we apply the formula? Well, you can simply apply the formula by doing, well, the first category, which is homework, right, times the percentage. However, I will turn this into a decimal, plus the other category times the corresponding decimal, and so on. At the end, you have the last one, which is 95 times 0.25. You can do that by hand, or divided by 100 or 1. Okay, you can do this by hand, or you can use the calculator. And on the calculator, in list 1, you put the scores. In list 2, you put the weight or the percent of final grade. Well, I suggest actually to put the decimal form of the percent. So on the second one, just put the weight as a decimal in this situation. And then when you get back to one variable stats, don't forget to do L1, comma L2, or just enter L1 under the first list and L2 under the second list. If you do that correctly, your answer will actually be X bar equals 89. So the grade for the student will actually be AB. And this concludes today's video.